Hello everyone. So this is week 6 assignment. So somehow the file got corrupted and I was not able to upload that on time, although the course is over. But anyway, I'm going to upload this today only, so that you'll be able to see the week 6 assignment. Um, I hope you gain some knowledge from it in solving those assignments. So let's just start with the questions. Um, so this is let's look at the questions. So uh, oh, the first question is so which of the following is or are true for Woodside structured compounds? So for Woodside structured compounds, the right answers would be cations occupy half of the tetrahedral voids. Uh, so that is A, and cations coordination number of both cation and anion is 4, and anions form 8 CP lattice with atomic positions 0, 0, 0 and 2/3, 1/3 and half. So the right answers would be uh, cations occupy half of the tetrahedral voids. So 1A would be cations occupy half of the tetrahedral voids. Okay, and that the answer B would be option B would also be correct, where coordination number of both cation, sorry, coordination number of both cation and anion is 4, and also anions from HCP lattice with atomic positions. Is the option D is correct. Anions from uh, HCP lattice with atomic positions 0, 0, 0 and the answer is 2 by 3, 1 by 3 and half. 2 by 3, 1 by 3 and half. Okay, so this is the first question. Okay, okay, moving on to the next question. Which of the following is or are correct for an elimination structure with chemical formula ABO3? So the answers are each A and B cations occupy 1/3 of the octahedral voids. Okay, so not all the octahedral voids are filled, but 1/3 of them are filled by each of the A and B cations. Okay, and the coordination number of anions is also 4. So the answer is A, each. Okay, so remember, just a second. let's just record on its own. Uh, yeah, so the second question would be, so let's just write it in here. So each A and B cations occupy 1/3 of the octahedral voids, isn't it? 1/3 of the octahedral voids. And the another answer would be the coordination number of anions is 4. And that is option your C. The coordination number of anions. Okay, that is that. Yes, based on the sharing of SiO4 polyhedra, which type of sharing is least preferred? For corner sharing and for edge sharing, they'll be widely separated. So from the perspectives of the nearing between the cations, there'll be repulsion. So in that case, the phase sharing scenario will have the least separation between the cations, and in that case the repulsion will be larger. Okay. So that will be least preferred. Despite that, corner sharing and edge sharing will be the most preferred, because in that case the cations are far apart, so there will be less repulsion between the cations. Okay, so the least preferred would be phase sharing, and that is the correct answer. Okay. Which category of silicate does muscovite belong to? So the category that muscovite belongs to is your sheet silicate. So Si2O5 2 minus, the 2 deficiency of 2 charges or valences. So the muscovite belongs to the sheet silicate group. So they are the sheet patterns. Okay, so it will be like the sheet patterns. Never mind, I'll just open this Google. Yeah. So you can see that for sheet like, it's muscovite, it is Si2O5 2 minus. Okay, so that is that. And okay, so out of the following, which material could be used in the electro-optic device applications? Okay, so among the given options, lithium niobate, like in BO3, so because it shows birefringence which is changeable by electric field, so it can be used in electro-optic applications, like in the electro-optic devices. So lithium niobate would be the best choice for applications in the electro-optic devices. Okay, so the right answer is lithium niobate. Okay, the type of glass, sixth question, the type of glass used in refractory applications is your fused silica. This is an informative question. So in refractory purposes, we use the fused silica. So seventh question, the number of oxygen atoms shared between the SiO4 4 minus tetrahedra in case of quartz. So for quartz, the number of oxygen ions shared is 4. So it belongs to the 3D network of SiO2 tetrahedra. So 3D crystal structure. So no deficiency. So it's basically the crystalline SiO2. SiO4 becomes SiO2 0 minus basically. So the number of oxygen atoms shared between the SiO4 4 minus tetrahedra in case of quartz are basically your four sharing oxygen atoms, okay, in quartz. Okay, so that is that. Which of the following type of polymers, question number 8, show translational mobility of polymeric chains at room temperature? So as far as the polymeric chains are concerned, so the elastomers, they show the translational mobility of polymeric chains at room temperature. Okay, so basically, yeah, translational mobility of chains at room temperature, they have a rubber like behavior, so they're called elastomers. Okay, so the elastomers show the translational mobility of polymeric chains at room temperature. The question number 9, which of the following is or are true for a thermoset polymer? So for a thermoset polymers, what happens is that there are large number of they have large degree of cross-linking between the chains. That is one correct option, and they decompose at high temperature, meaning that if you expose it to higher temperatures, it will not melt, it will be decomposed. Okay, so that is what happens for thermosets polymer. Okay. Okay, so if the degree of polymerization is 30,000, the average molecular weight in atomic mass unit of polyethylene is C2H4NaS. Basically, what you have to calculate here is that question number 10. Question number 10. First, you have to molecular weight of carbon, which is around 12. Okay, and molecular weight of hydrogen is equal to around 1. So basically what you have to do here is basically C2H4 means 12 times 2. C2H4 means 12 times 2 is 24, and 4 times C2H4 means 12 times 2 equals 24, and C2H4 uh, 1 times 4, which is equal to 4. Okay, so in total that is 24 plus 4 is 28, and you are asked that the degree of polymerization is 30,000. Okay, so you have to multiply this number with 3, so that will get you the right answer. Okay, that is 84 840 and 84 zeros. Okay, 8,40,000. Okay, so that will be the molecular weight of polyethylene chain, which has 30,000 monomers attached. Okay, so the correct answer is 8,40,000. Similarly, you can work out the 11th question. Calculate the molecular weight of C8H8 and multiply it by 1200. That will fetch you the right answer. Okay. The example of thermoplastic polymer is thermoplastic polymers. Basically, what you have to consider is they soften with temperature and followed by melting. They have little cross linking between chains. They are ductile. So the typical examples are polypropylene, okay, and polycarbonate. Okay, so they basically soften with temperature. So you have to think about that one. The side groups in polypropylene, when you consider polyethylene, there are only C2H4 monomer chains cross-linked. Okay. Now, if you replace one H with chlorine, in that case, that becomes polyvinyl chloride, which is PVCs. And if you replace with the group CH3, that becomes polypropylene. Okay. That is basically C2H3 and one hydrogen replaced by CH3, and this monomer unit is repeated. Okay, so the side groups in polypropylene are H, H, and 3 H's and CH3. Okay. So the 14th number question: which of the following results in an increase in the melting temperature of polymers? Okay, so the answer is presence of double and triple bonds. Why so? Because in case of double and triple bonds, it will enhance the bond energy and as a result, it will require more bond energy to dissociate. Okay, so more energy to dissociate the bonds, and that is why the melting temperature of that compound increases. Okay, and presence of bulky or large side groups. The same reasoning in that the bonding energy is higher, it will require more energy to dissociate. Okay, so presence of bulky or large side groups and presence of double and triple bonds. Okay, so and 50. This is the last question. Pick the correct statements in the following. Okay, okay. Each carbon, so the right answers are each carbon atom in polypropylene is tetrahedrally bonded to four neighbors with bond angle of 109.5 degrees. That is, you saw in the lecture itself. Okay. Only two-thirds of the octahedral voids are filled by the cations in corundum structure. You already saw in the lecture, that is correct. The addition of impurities to silica decreases the glass transition temperature, because in that case it lowers the glass transition temperature, and that is why you employ that phenomena to give different shapes to the silica. Okay, so these three are the correct answers. Okay, so now we are done with our lecture, so let's just share. Okay, thank you.